For this part, I would suggest you first review element number 6 because we'll be building on top of it. This you can recognize as the unit circle. On the unit circle, we can measure distances on the x and y axis, such that distances on this side are positive and this side are negative, and distances on this side are positive and on this side are negative. Also, we can measure angles. Each point here on the circle we can associate with some angle. For example, this point we associate with the angle beta, which you can imagine as we rotate this ray starting from here, and then we start rotating it like this, and we rotate the angle beta. And that's why the arrow here on the angle beta you can see, because we rotated it from here to here, and the amount we rotated is the angle beta. So each angle beta we can associate with some distances on the x and y axis. For example, this angle beta, we draw this ray, and then we drop perpendiculars here and here, and then we measure these distances. And these distances we call the cosine of beta and the sine of beta. And for each beta, we're going to have a different value for cosine of beta and sine of beta. For example, if we took beta to be smaller angle, we would have this ray here, and we would have to drop perpendiculars from here, like this and like this. And so the cosine would be larger, and the sine here would be smaller. Also, notice that we measured the cosine on the positive side of the axis, not on the negative side. And we measured sine beta on the positive side of the other axis, not on its negative side. And so sine beta and cosine of beta are going to be positive. Furthermore, note that instead of taking angle beta, if we took the angle 360 degrees plus beta, we're going to have a rotation from here 90, 180, 270, and then 360, and then beta more. This would be 360 plus beta. And we would get exactly the same ray. So we would get exactly the same value for the cosine and the sine. Now let's try and see what's sine of 0 and what's cosine of 0. Now remember that the cosine is the horizontal component and the sine is the vertical component. And now to understand what's sine of 0 and cosine of 0, we should move this point such that angle beta becomes 0. So we have no rotation essentially, like this. And then the horizontal component, as you can see, the horizontal component becomes 1, becomes equal to the radius of the circle. And the vertical component becomes essentially 0. And so sine of 0, which is the vertical, is 0, and cosine of 0, which is the horizontal, is 1. Now let's try and see what's cosine of 90 degrees and sine of 90 degrees. So we need to move the point such that beta equals 90 degrees. And now we can see that the horizontal component becomes essentially 0. So cosine of 90 degrees is 0. And the vertical component, which is this one, it equals 1 because it is the radius of the circle. And so sine of 90 degrees is 1. Now let's see what happens, for example, when beta becomes larger than 90 degrees. Well, let's move the point a little bit and see where the sine and cosine lie. Well, the sine is this vertical component here, which is on the positive side of the y-axis, so the sine is positive. But the cosine now lies on the negative side of the x-axis, and so the cosine of this angle beta is negative, which means that for angles between 90 and 180 degrees, we have that their sine is positive because it lies on this side and not on this side, and their cosine is negative because it lies on the negative side, not on the positive side. So this distance will be the cosine with the negative side, and this distance is going to be the sine with the positive sign. So then, for example, if I ask you, is the cosine of 95 degrees positive? You can say no, the cosine of 95 degrees is negative because the horizontal projection of this ray lies on the negative side of the x-axis. And the sine of 95 degrees is positive because it lies on the positive side of the y-axis. Next question. What is the sine of beta minus 360 degrees? Well, let's see. A sine of beta, and then we subtract 360 degrees. So we start rotating in the opposite direction, subtracting 360 degrees, and we get right where we started, here. So the sine of beta minus 360 is, again, the length of this segment with a positive sign. And so it equals sine of beta. Sine of beta equals sine of beta minus 360 degrees. And the same applies for the cosine, of course, because the ray is still the same, whether it's beta or beta minus 360 degrees. So cosine of beta equals cosine of beta minus 360 degrees. But what if the angle beta is greater than 180 degrees, but less than 270? For example, if we put it here, well then the sine is going to be here, so it's going to be negative on the negative side of the y-axis. And the cosine is also going to be negative. So the length of this segment, negative, and sine is the length of this segment, which is also negative. And the last case happens when the angle beta is greater than 270 but less than 360, like this, in which case you can guess that the cosine is on the positive side of the x-axis, so the cosine is the length of this projection here, which is positive, and the sine is still negative because it's on the negative side of the y-axis, and it's the length of this segment right here. The optional problem is to solve this equation, sine of alpha equals cosine of alpha. And here is the solution. We need to find for which angles alpha, sine of alpha equals cosine of alpha. So let me draw the unit circle, and then the x and the y-axis, and this is the positive, positive, negative, negative side. I'm going to start traveling around this circle, and I'm going to see when sine of alpha is equal to cosine of alpha. So starting here from 0 degrees, here sine is 0 and cosine is 1. So sine of alpha is not equal to cosine of alpha. By increasing the angle and decreasing the cosine, because now the horizontal projection becomes smaller and smaller and smaller, and I'm increasing the sine because the vertical projection becomes larger and larger and larger. So now when I increase the angle, I'll reach a point when the vertical projection and the horizontal projection become equal. And hence, at this point here, we have a square, because it's anyway a rectangle, but right now the sine, which is this vertical part, and the cosine, which is the horizontal, are equal. And so the rectangle is a square. And because we have a square, we have 45-degree angle here and here. Of course, because of the congruent triangles, this triangle here has the same sides as this triangle and the same angles. And so this angle equals this angle, and because their sum is 90 degrees, each one of them should be 45. The sine of 45 equals cosine of 45. I'm going to continue traveling along the circle. So right now the sine is getting closer to 1 and the cosine is getting closer to 0. Now the cosine is exactly 0 here and the sine is exactly 1. Now the sine starts getting smaller and smaller, and the cosine also is getting smaller because it's becoming negative. At this point here, the absolute values of the sine and the cosine may become equal. The sine here is positive, but the cosine here is going to be negative. So in this quadrant, it's impossible the sine and the cosine to be equal because one is positive and the other is negative. So I'm continuing from here. Now here both the sine and the cosine are negative because the cosine is here and the sine is here. So there will be a point right here in which the value of the cosine, which is this projection, and the value of the sine, this projection, are going to be equal. So horizontal equals vertical. And therefore, this is also a solution to our equation. As in the previous case, we find that this angle here equals this angle here equals 45 degrees. And so the angle that corresponds to this ray right here, that's the solution to our equation, the angle is 180 plus 45 more. So it's going to be 225 degrees. And now I'm going to continue moving this point, increasing the angle. Right now the sine is becoming more and more negative, closer to -1, and the cosine is becoming closer to 0. At this point the cosine is 0 and the sine is -1. And here in this whole quadrant, the sine is going to be negative right here and the cosine is going to be positive right here. So it's impossible for a negative number to equal a positive number. So there's no solution all the way up to here. And so these are the only two places on the circle where the cosine and the sine are equal. But are 45 degrees and 225 degrees the only solutions? Well, no, because we can add and subtract 360 degrees without changing the values of the sine and cosine. For example, sine of 360 plus 45 is going to be 360 plus 45 more. So it will mean that the ray got unchanged. And for this angle, it is still true that sine alpha equals cosine alpha. And what about 225 degrees plus 360 more? Yes, it still represents this ray here, so it represents a point on the unit circle from which the horizontal projection and the vertical projection have equal lengths, which means that the sine equals the cosine. So we can write the solution as alpha equals either 45 degrees plus some multiple k times 360 degrees for k equals, so k can equal 0, 1, 2, -1, -2, so some whole number, some integer. Or it can be 225 degrees plus k times 360 degrees, for k another integer. Or we can write this expression in a shorter way like this: 45 degrees plus k times 180 degrees. Because see, when k is 1, we're going to get 45 plus 180, which is 225. When k is 2, we're going to get 45 plus 360. When k is negative 1, we're going to get the same thing as 225 minus 360 degrees, and so on. And you can see this on the picture. It is 45 plus some multiple of 180. 1 times 180 will get us here. 2 times 880 would get us here. Or maybe we start at 45 and then we subtract 180, we're here. We subtract 180 more, we get here. In any case, when we add or subtract multiples of 180 from this point, we're either going to get here or we're going to get here again. So these are the only 2 points on the unit circles we can get from this expression. And for these 2 points, we saw that the sine and the cosine are equal. So this here is the final solution of our equation.